Today we're talking about 9.1, which is about interpreting graphs. This is the beginning to our new unit, chapter 9, which is about statistical representation. So in the previous chapter we had talked about some various methods of finding probability and some statistical calculations. Here we're going to talk about some ways to represent that information visually with the graph in this case. All right, so there's types of graphs. The first type we're somewhat familiar with are bar graphs. And let's see if I can write this in here. And our bar graphs, just like any of our graphs, we should have certain things so we can identify what's on the graph or what the graph is showing us. I'm going to slide this over just a little bit. Okay. And so one of the things we have to make sure every graph has, they must have a title. Okay. There are different axes. Now it's not like our XY coordinate plane, like the full plane where we have, positive up and then negative down, positive to the right and negative to the left. It's as if we only have the positives here, okay? As if we just have, y-axis going this way and x going that way. So you'll have titles on the axes, okay? So, or we also call these labels, but this book calls them an axis title. And it just tells us, what is represented on each side, right? Then, in this case, I have some grids on mine already marked, or some lines. Some graphs will have some thinner ones, or maybe they just have some smaller lines kind of in the middle, okay? These are called our grid lines, and you can have the major grid line, which is dark, and any minor grid lines that are lighter or smaller. And because it's a bar graph, we also will need to know what the scale is. So whether we're going up by 1, every major grid line, so if these are halves, are they going up by 10, 20, are they going up 100? What is the scale? So, and that's usually found on, this edge here. And you can determine how much it goes up. And then because it's bar graph and not a line graph, along the bottom, we're going to have categories. All right. The example they have in your book, they show votes for school president, right? And so the title they have on the bottom are the nominees. On the side, they have votes. And then for us to be able to determine how many each person got, we have to have the category label of the name of each person. And then it shows a bar going up for how many votes that each person received. Okay, and you can see that in your book on page 418. It is important to note that there are both vertical line graphs or bar graphs where the bars go up and down. And there's also horizontal bar graphs where the bars go this way, okay? Let's see. Slide this over a little bit. All right. I might just sketch the next one on here. Let's talk about the example. So you will have to look in your book for this example, but of course put this in your notes so you can have this as a layout to kind of understand the basic format for the graphs. But the question says, answer the questions about diameter of planets. And you can see that the title of the graph is diameter of planets. We see on the side axis there that title is planets. And then on the bottom, that axis title is diameter. And it says it's in 1,000 km. So we know that every, single one of these marks here represents 1,000 kilometers, or each number is 1,000 kilometers. So when we see 10, we know it's not just 10 kilometers, it's 10,000 kilometers, all right? And then we see that it has like the minor grid, the little lighter colored ones, and those would be worth 5 each, okay? So then it says, so that's the first thing you want to do when you see a graph, is really look at what is being shown, identify the scale, and make sure you know if there's any special things, like in this case, it was by the 1,000 kilometers. Letter A says, which planet has the largest diameter? Well, in a bar graph, you can just look at it. Instead of having to like read and count all the numbers, you can visually see either which one is the tallest, or in this case, which one goes out the furthest for that horizontal bar. And we can see easily that Jupiter goes the furthest. The next question says, which planets are less than 40,000 kilometers in diameter? So to find out which ones are less than 40,000, we're going to go to 40 on the graph and see which ones are shorter or didn't touch that line. And we can see that there's Mercury, Mars, Venus, and Earth. And in letter C, what is the approximate diameter of Earth? And so we would go and find the bar for Earth. And it happens to fall between the 10 and then that minor grid line of 15. So halfway between 10 and 15,000 kilometers. So we're going to estimate that to be about 12,500, because the 2,500 will be halfway for 5,000. Okay? All right, so that's bar graphs. And again, I didn't draw a lot on here for the bar graph, but I guess I could sketch a little bit of a bar here that shows that these can go, this direction, It's also important to notice that when we do our bar graphs, that there's spaces in between the bars. Don't make them all touch, okay? They should all have space in between them. Sometimes, or some texts I've seen, they prefer that you have the size of one bar in between the bars. Like if these are each 2 squares, then I should leave 2 squares in between. I'm not such a stickler on that, as long as there's some space in between the bars and that it's the same as you go across. I wouldn't want to have one where they're, only one wide and one's, I want to keep them the same all the way across the graph. Okay? All right. Let's look at the next kind of graph. And this is a stacked graph. Let me insert another table here. And I'll try to sketch this one. And this is on page 419. In a stacked bar graph, it's as if they were able to overlay multiple bars on the graph. Or they're showing different colors on each bar, and each color represents a different category. They're also known as segmented bar graphs, and you're able to represent several categories in a single bar. The height of the entire bar represents the total of all of its categories, okay? Each category we can find in a legend or a key that tells you which color represents each category. Let's see, so this one we're going to sketch here from the book has the title Summer Reading. And on the side axis here, we've got number of books. I'm kind of just abbreviating here. Now, we see the scale. We've got 0, 20, 40, 60, all the way up to 140. I might be able to sketch it more like theirs. I was trying to see if I had enough boxes, and I think I do. So they have major grid lines and then the minor grid lines. I'm going to use these, just kind of skip a line. So there's 10, 20, 30, 40, 50, 60, 70, 80. Nope, I don't have enough. Sorry. If you're sketching along with me, just bear with me. I thought I had more boxes than I had. So 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Now, the graph in the book doesn't go to 200, it stops at 140, but that's okay. And we'll consider the halfway to be the minor grid lines. Alrighty, so we've got 7th grade as a category here, or as a group. Then we have 8th grade and 9th grade. And then we see various categories. We have the fiction category, which is this lighter blue color. And then we've got nonfiction, which is kind of red. And then we've got, and kind of a yellowy green, biographies. Okay, so for the 7th grade fiction, we see that the blue category goes up to between the 20 and the 40. So right in here. Make my pen a little wider. All right, then we see the category for nonfiction on the top of that goes up to between 40 and 60. And then biographies start there and go up to between 80 and 100. Okay, and we'll see. I mean, I have time to sketch all of these in, but I just kind of wanted to explain what this is. So when I look at this, I can see that for 7th grade, if I look at the entire stack, it'll tell me the total books altogether for 7th grade. That it stops here, well, it should have been right between 80 and 100. So I know that the 7th graders read a total of 90 books. This section here tells me how many fiction. It starts at 0 and goes to right in the middle, so 30. So there's 30 of these. But this middle section, it's talking about going from 30 up to 50. So I know in here, that represents 20. And then from 50 up to 90 would be 40. So again, you're not able to look, straight across to get the value for the single section. You do have to subtract to figure out the amount of space, in that section. All right. But you can tell, more easily, oh, well, I can see, well, the biggest, the most books they read came out of the biography versus the other two categories. So again, that's a benefit. And then the other ones you could then easily compare how, wide or small. The other bands were on the 8th grade and 9th grade, which you can see in your book, okay? But I just kind of wanted to explain what that is. Now, stacked bar graphs can also go horizontal. They don't have to be vertical. And sometimes they'll show them like side by side. Like instead of making these individual, they might have had making one stack, they might have had a blue one, and then next to it had a red, and then next to it had a green. So you'll see this kind of different types of graphs, just depending on what you're wanting to convey. Remember that when you're presenting information in a graphical format, you're thinking about who's going to look at it and what they're going to want to know, and how easy it is for them to find that information from your graph. Don't make it too complicated, is what I'm saying. All right, the last kind of graph is a circle graph. And we've seen circle graphs before. We know that a circle graph represents the data in a circular format, where we know that all of this together would be, the total number of whatever you're comparing. And then the sections or the pieces of the pie, if this was a pie, right, would represent the portion that came from that category. So on page 420, they have an example of one. And let's see. See if I can sketch the one they've got here. I'm going to make this a little skinnier, just to make it a little more obvious. All right. And this is the one from example 9.18. Sorry, 9.1b. It looks like an 8. 9.1b. And they filled in this first side here with purple. And having a circle graph is also nice because you can easily look at the graph and tell immediately which is the largest, which one is the smallest, when you're comparing the values. So we can easily see that this one is the smallest amount, and this one's a little bit larger. And that this piece is the next to the biggest. Now when we look at circle graphs, there's two pieces of information they can show us. They can give us the data just as numbers, or they can give it to us as percents. And on this one, they've shown it as percents. They're telling us that this purple section is 54%. And you can tell it's just slightly more than half. The green section is 31%, the red section is 10%, and the blue section is 5%. Now, just having this graph with the numbers on it, I don't know what it's about. I have no idea what I'm looking at. I have to have a title. And this one, the title is Composition of Barrel. Okay, and then we're told what the colors represent. All right, the blue section is beryllium. The red section is aluminum. The green section is silicone. And the purple section is oxygen. So let's see what kind of questions they're asking us about our circle graph. The first question says, which element is the most abundant in beryl? Well, we can just look at it and say, well, obviously this big purple section, it would be oxygen. Letter B says, if the sample of beryl had a mass of 300 grams, what is the mass of the silicone? Okay, so and this is where the percents are going to help us to calculate or find this answer, all right? So I didn't need the percentages necessarily to determine which one was the largest, but I do need it when I want to calculate the amount of silicone. There would be, if the sample size was 300 grams. So to find that, I need to figure out, well, if I've got 300 grams, I need to know 31% of 300. Well, we know to find 31% of, we're going to multiply it, but we have to change our 31% into a decimal, so 0.31. So 300 times 0.31 should give us 93 grams. Okay? So being able to go from the circle graph to answer just some comparison questions, but then also using the data from the graph to calculate a value. All right. So in the lesson, we'll do part of these. Let me see if I've got enough. Oh yeah, we can do line graphs. Let's do one more. This might be a little much. No, I don't want that one. Okay, I thought I had a different one that I could use, but we'll just use this one. So the main thing that's different with the line graph compared to our bar graph is that we're going to have numerical values on both sides. On the bar graph, we had some labels or categories on one side with a scale on the other. For the line graph, there's going to be a scale on both sides. And so we'll go ahead and look at the example here. We'll make this example 9.1c. And our title is Progress in Keyboarding. And I may not be able to fit all of it on here because my little graph is not long enough. But we can see on the side, they've got WPM, which means words per minute. Down in the bottom, we've got weeks, and they're going in order. So we've got week 1, week 2, 3, 4, 5, 6, 7, 8, 9, and 10 for my graph. Goes a little further on the other one. And then they're going up by values of 10. So 10, 20, 30, 40, 50, 60. Okay, it's about as high as that one's gonna go. And then we notice on the side that we have a little bit of a legend with the colors. We see that the blue line is for Chandler, and the red line is for Chelsea. All right, so what they've already put on here, they may have us plotting some in the homework, but but this one was already given to us. We see that week 1, Chelsea has 20 words per minute. Week 2, she's gone up to 25. Week 3, she's up to 30. Oops. You can see I went in the middle there, but because it's by the weeks, I needed to go on the line. There we go. That's better. Week 4, she's at 30. Nope. 35. And then week 5, she's up at just above 40. And then week 6, dip down to 35. Week 7, just under 40. And then week 8 at 40. And 9 is just above 40. And then 10, just above 45. All right, so I've got Chelsea's on here, and this is a line graph where it's not smooth, it's not a curved line. They really kind of connect the dots on this kind of a graph. Now, by putting Chandler on the exact same graph, it allows you to compare week by week and then overall progress for both. So Chandler started out really strong. His first week, he was already up at 30. Oops, but he's blue. So 30, and then kind of here. And then he dips down for week 3. And then he goes back up. Well, he's right where Chelsea is. Then week 5. Week 6. Week 7. Oops. Week 8. 9. Oops, I keep putting them on the wrong line. 9 and then 10. They're kind of right neck and neck here, like that. Okay, so again, it gives you just an idea of kind of the progress of the two students, and then you can, answer questions about it. One thing I do want to mention, if you look at my graph compared to the graph in your book, even though the data is exactly the same, the fact that the spacing between my bars are a little shorter, and so it kind of, I don't know, it doesn't look as close on some of the areas as it does, or stretched out as it does in your book. You want to be very careful of that. If you're comparing information on a graph, to make sure that you kind of see how the graph is represented. Since I've got more space on mine, my graph has more room to kind of be taller and show a little more fluctuation, whereas your graph looks more stretched out. So just kind of be aware of that if we're making graphs, particularly on a computer, that you can kind of adjust how things look, and you might even kind of skew your data a little bit, so be careful with that. All right, so the question says, during which week did Chelsea have the highest words per minute? So for Chelsea, her highest words per minute happened to be her very last week, week 10. In which weeks did Chandler have a higher WPM than Chelsea? Well, we can see he was higher on week 1, week 2, week 6, week 7, and week 9. And then who had the highest words per minute? Well, Chandler got the highest. He got 50 during week 9. So out of all the entries, that was the highest one. All right. When the graph looks like this, when the lines are kind of very straight lines to connect between the dots, we call that a broken line graph. If we were to, kind of flow through these, and I'll kind of, let's see if I can, all right. Let's say, for example, this was a curved graph. You might kind of flow through the data a little more like that, which would be a curved graph. There are certain situations where a curved graph makes more sense. In this situation, the broken line graph was better. And then there are some where it's perfectly straight, that like we saw when we did the algebra sections, where you end up with a linear equation that make you a perfect straight line, okay? So we're gonna talk all things graphs in this section, 9.1.